This video is going to take a look at reviewing matrix operations, or maybe if you haven't worked with matrices before, it'll kind of establish the basics of matrix operations that we're going to need in our differential equations class in order to solve systems of equations. We're not going to go deep in the theory, we're just going to cover what we need to know to answer the question, how do we do operations with matrices? In fact, I'm going to only look at the cases of matrix operations that are becoming useful to us as we solve differential equations, systems of differential equations specifically. One thing that we need to do is a little bit of vocabulary. Often we'll talk about a matrix, which is just going to be some rows and columns of values. And our textbook puts them in parentheses. Most textbooks put them in square brackets. So if you see a different textbook, that might be the reason why. But a matrix is just some rows and columns of values set up. Now, if we specifically refer to a vector, that's generally going to refer to a matrix that only has one column. However many values in it might change, but it's only got one column. So if we want to look at adding matrices and vectors, what we do is we just add the similar locations. So, for instance, if I wanted to add two vectors, let's say I had the vector 4, 7, and I wanted to add to it the vector -2, 3. Well, all that's required there is to just add the like position, 4 and -2 in the top position, and 7 and 3 in the bottom position, to give us this solution vector of 2, 10. We can also add matrices in much the same way. Let's say we're adding the matrix 2, 3, -2, 5, plus the matrix 4, -3, 7, 1. So these are 2 by 2 matrices. So in the top left corner, we're just adding 2 plus 4 to get 6. In the top right corner, 3 minus 3 is 0. In the bottom left, -2 and 7 is 5. And in the bottom right, 5 and 1 is 6. And now we've got our sum of these two matrices. Another operation we'll often have to do is we're going to multiply what's called a scalar times a vector. Or it could be times a matrix as well, because a vector is a special type of matrix. A scalar is just any constant or any number. It might even be a function or an expression in terms of a variable that is not part of the matrix. What we do to multiply a scalar times the vector is we multiply each element by the scalar. Here's what I mean by that. We might have a scalar of 5, that's just a number, times the vector 2, -3. And what that means we're going to do is we're going to multiply each element in that vector by the scalar of 5. 2 times 5 is 10, -3 times 5 is -15, and we have our product. Similarly, if our scalar was a function, maybe e to the 3t, times a vector, maybe it's 4 and sine of t. What that means is we're going to multiply each element by the scalar. 4 e to the 3t, and e to the 3t times the sine of t. So scalar multiplication is quite simple. A little more involved is multiplying a matrix times a matrix. So let's take a look at multiplying matrices. When we multiply matrices, what we want to do is we want to make sure we multiply rows times columns. So for example, if we have this matrix, we'll just call it generically A, B, C, D, and I multiply it by the matrix EF, what we're going to do is this first space represents the first row and first column of my solution. So we will multiply the first row and the first column of these matrices. And when we do, we have A times E, and we will add the second elements, B times F. Then underneath it, we're going to have what's represented by the second row, first column. So doing the same thing, we'll multiply C times E and add to it D times F to give us our solution. So for example, if we had the matrix 3, -2, 4, -5 times the vector 1, 3, we would set it up by first multiplying the first row times the first column. So 3 times 1 gives us 3. -2 times 3 gives us -6. Then we'll multiply the second row times the first column to get our second row, first column solution. 4 times 1 is 4, and -5 times 3 is -15. And then all we have to do is simplify that. 3 minus 6 is -3, and 4 minus 15 is -11. And we have our product. Let's do one more matrix multiplication. Let's do 2, -3, 1, and -7. And we're going to multiply that by 4, -5. Again, for the first row, first column, we multiply first row times the first column. 2 times 4 is 8. -3 times -5 is +15. Then we can do 1, -7 times 4, -5. 4 times 1 is 4. -7 times -5 is a +35. And then we just have to finish it out by doing the subtraction and addition. 8 plus 15 is 23. 4 plus 35 is 39. And we have our solution vector. Now we've taken a look at multiplying a 2 by 2 matrix by a 2 by 1 matrix. And when the matrices get bigger, the multiplication does become more involved, but we're not going to be doing any of that in our differential equations class. So I will save that lesson for your linear algebra instructor to show you. For now, I hope this video was helpful in reviewing how we multiply matrices by a matrix, by a scalar, and also how we add vectors together.